you are watching 99.9 Engineering Station. So student, today's MCQ for the day is from the subject thermodynamics, and the question is, if the temperature of the saturated water vapor is increased infinitesimally at a constant entropy, so the resulting state of the water will be, we have a four option. First one is liquid, second one is saturated vapor, third one is liquid water coexist, and the fourth one is the solid. Okay, so we have a four state of water which may be the answer. Okay, so in the question you can see that we have to find out the state of the saturated water. We have to find out the state of the saturated water at constant entropy. This is very important point in the question, that it is given that we have to find out the saturated water state at a constant entropy and the temperature is constantly increases. Okay, so you can see that in the question the main concept behind this question is about the entropy. So it is not compulsory that every time this type of question is asked by the examiner. Okay, so we have to understand, it is very important that we have to understand the concept which is used in this numerical or is in this theoretical problem. Okay, so for that I am going to explain you the concept of entropy, how entropy is changed with the heat input, and the change of the entropy in the two different process, like reversible process and the irreversible process. So let's discuss. Okay, so you can know that the entropy is the property, not a quantity. So here I am going to give you a short note on the entropy process. Okay, so you can see that the for the reversible process for the irreversible process we have a two different formula for the entropy change. The first process is here I have noted that the reversible process, and for that the entropy change will be ds is equal to del q by t for reversible. This is very important formula for the reversible process, that ds is equal to del of q upon t for reversible process. Okay, here the del of q is the change in the heat input. Okay, and the ds is the quantity, as I said that the ds is the property, and we are taking the net entropy change. Okay, it means ds is the final entropy minus initial entropy. So the formula for the reversible process is ds is equal to del of q upon t upon for the reversible process. Wherever if we talk about the irreversible process, the formula will for the entropy change will be ds is equal to del q by t for irreversible process plus del of s is the generation, del S generation. It is the amount of entropy which is generated in the process, during the process. So though you can see that the value of del S generation is always will be positive because it is added to the process. If the value of, as the temperature, we increase the temperature of the process, the del S is increases constantly. Okay, so if we decreases the value of del S generation, it means if it goes to equal to 0, the irreversible process become the reversible process. You can see in the numerical, if this value will be 0, it is equal to the reversible process formula. This formula become equal to the almost equal to the reversible process. That's why we can say that the irreversible process, for the irreversible process, the del S generation is always we are taking is positive. Okay, so this is all about the basic formula of the entropy for the two different process. for reversible process and the irreversible process. Okay, now we are going to discuss about the entropy change of the system for two different process, like irreversible process and irreversible process. Okay, so as we know that the when heat is added to the system, it is taken as a positive, and when heat is removed from the system, it is taken as a negative. Okay, so we have to find out the entropy change of the system for the reversible process. For first case is for the reversible process. Okay, so when we have a three condition, for that we have to find out the entropy change. Okay, so when the heat is added to the system, when we added heat to the system, it means we added the heat in positive quantity. It is a positive quantity because I have said already that earlier that when heat is added to the system, it is taken as a positive. Okay, so first case is that when heat is added to the system, you can see, come to the formula of the reversible process. This formula is applied in this case. So you can see that if del S is added to the system, it means this quantity will be positive. Okay, this quantity will be positive. It means ki we got the final change of the entropy, which is the final entropy minus initial entropy. From this expression, we also get the entropy is a positive quantity because del Q is a positive quantity. Okay, it means when heat is added to the system, automatically from the result that ds is also increases. Okay, when heat is added to the system, then the change in entropy is also increases. So I have written down in the in a very short way that when heat is added to the system, ds is also increases. Okay, ds is also increases. Now come to the second point, that is when heat is rejected from the system. It means when heat is removed from the system, we can say, we take a heat as a negative quantity. So okay, so come to the this expression, that is reversible process. For the formula for the entropy change for the reversible process, that is dq upon del q upon t reversible. So if in case of heat rejection, the value of del Q will be negative, it means we get the change in entropy is also negative. It means automatically we get the expression, that is del S will be decreases. When we rejected heat from the system, it means the change in entropy is also decreases. So I have written in very short way this also, that when heat is rejected from the system, the value of ds is also decreases. When heat is rejected, the value of ds is decreases. Okay, so this two case when we have discussed that when heat is added to the system and when heat is rejected to the system. So what will be the case when we take a system where when the reversible adiabatic processes exist? Reversible adiabatic process means the value of del Q is equal to 0. The adiabatic condition is that when the heat change is not taking place. So the last case is when the reversible adiabatic process, then in that case the value of del Q will be 0. So the value of if the value of del Q is 0, it means the entropy changes also we get is 0. That means the entropy change is constant, and that when the entropy change is constant, in that case or equal to 0, in that case we said that this process is isentropic process. Okay, the process which has entropy constant or entropy 0 is, in that case the process is isentropic process. Okay, so I have written in this way that when the reversible adiabatic process exists, that in that case ds is equal to 0, and this type of process is called isentropic process. Okay, so these three cases is for the reversible process. And now come to the irreversible process, that the irreversible process, here we also discuss the same concept of heat adding or heat rejection. Okay, so when we heat added to the system, so what will be the case for heat adding to the system? So you can see in the formula of the irreversible process, the formula is ds is equal to del q upon t irreversible plus del s generation. Okay, so you can see that the value of del s is always positive. Okay, always positive. And if we added del q to the system, if we added heat to the system, what will be happen? Suppose we have ds is equal to some amount of heat entropy generation is, suppose we have a entropy generation of 3. Okay, suppose we have a entropy generation of 3, and the second concept is heat is added to the system, some amount of heat added to the system. It means we added positive quantity. Suppose we have positive 2 quantity, then the entropy change we get is positive 5. Okay, positive 5. In that case, what will be the resultant ds is positive quantity. Okay, it means when we heat is added to the system, ds is always increases. ds is always increases. Okay, then come to the second case. Just a second. Now come to the second case when heat is rejected to the system. So what will be the cases for that when heat is rejected to the system? In that case, suppose we have a negative quantity. Okay, so in that case ds is equal to minus, suppose we have a del s by t quantity for the reversible system is 2, and we have a q del q s generation is 3. In that case ds we get is positive 1, and that is positive quantity. So when heat is added to the system, we also get the positive quantity when we added. So it means in the case of rejection we get all type of entropy. The first case is entropy is increases, and suppose we added is minus of 4 plus what quantity, minus 4 plus 3. Okay, in that case we get minus 1. In that case it means the entropy change will be negative. It means what will happen, when heat is added, the entropy is decreases. Now come to the third case when heat is added to the system. Then if another example for that suppose we have a 3 plus 3. In that case we get ds is equal to 0. Okay, so you can see that all the cases exist in the case of irreversible process when heat is rejected. And in the third case, this condition is for the isentropic condition, isotropic process or system. It means कि हमें क्या आइसेंट्रोपिक प्रोसेस रिवर्सिबल प्रोसेस में भी मिलता है और साथ में इरिवर्सिबल प्रोसेस में भी मिलता है. तो ये क्वेश्चंस बहुत मेनी टाइम गेट एग्जाम में पूछा गया है कि जैसे हमारा आइसेंट्रोपिक प्रोसेस है वो रिवर्सिबल प्रोसेस है कि इरिवर्सिबल प्रोसेस है या दोनों में एग्जिस्ट करता है. इट मीन्स हम कह सकते हैं कि आइसेंट्रोपिक प्रोसेस जो ये इरिवर्सिबल प्रोसेस में रिवर्सिबल प्रोसेस में एग्जिस्ट करता है और साथ ही साथ इरिवर्सिबल प्रोसेस में भी. लेकिन ये ज़रूरी नहीं है कि आइसेंट्रोपिक जो सिस्टम है, आइसोट्रोपिक प्रोसेस है, वो ऑलवेज रिवर्सिबल प्रोसेस हो, वो इरिवर्सिबल प्रोसेस भी हो सकता है. ठीक है, तो ये सारी चीज़ें थी हमारी इरिवर्सिबल कंडीशन के लिए, जिसमें हम जो है we cannot say that the heat rejected from the system. In the case of irreversible system, the ds value may be increases, may be decreases, or it will be equal to the 0. Okay, now the third condition, that is isentropic adiabatic process. In that case, isentropic adiabatic condition, you can say that ds, we have a ds value and some amount of del q upon del T irreversible, we have this formula, and heat generation. Okay, this is the heat generation. You know that this quantity is always positive, and if the value of this is 0 and this will be the positive quantity, the value of ds is automatically what? It is a positive quantity. That's why in the case of irreversible adiabatic process, the value of ds is always increases. Okay, so this is all about the process, irreversible process condition when heat is added or rejected, or it will be a 0. Okay, now come to the next thing you have to know, that the entropy principle. So what will be the entropy principle? That is del S universe is always equal to 0. Del S universe is always equal to 0. Del S universe is always equal to 0, and in case of del S universe we can write it as the del S of system plus del S of surrounding. You can you know that the universe is the summation of system and surrounding. That's why we can write this principle as a del S system plus del S surrounding is equal to 0. So for the reversible process, the condition for this entropy principle will be del S plus del S system plus del S surrounding is equal to the 0. When the del S system and the del S surrounding addition of this universe is equal to 0, then the process will be reversible process. Okay, then the process will be reversible process, and when the del S system plus del S surrounding is greater than the 0, then that process will be the irreversible process. Okay, that process will be the irreversible process. And the third option, when the process is not exist, that is del of system plus del of surrounding is smaller than the 0. In that case, there is no possible condition for the process formation. Okay, so this is the how the entropy principle work. Okay, so now we are going to lastly come to the entropy TS diagram. About the TS diagram, you can see that if we draw the TS diagram in the plot, you and the some reversible system and this type of path we get. In that case, the value the QR generation for the reversible process will be area under the curve is what? We get some amount of ds and ds area and at the temperature T. So the area of this small particle, a small section, will be TDS. Okay, so that's how we get the reversible heat generation from the TS diagram is from stage 1 to 2 T integration T dot ds. Okay, so this is all about the main basic thing about the entropy, that how the entropy change and how the entropy taken as a constant. Okay, now come to the question that if the temperature of the saturated water is increases at a constant entropy, the resulting state of the water will be. So in that case, when we increase the temperature and we taken as an entropy constant, in that case the state of the saturated water cannot be change is not taking place. So the state of this state of the saturated water is also a liquid state, because saturated water is in the liquid state and there is no change in the state at a constant entropy by increasing the temperature. That's why the state of the system is also a liquid because the saturated water is in the liquid state. और तो कोई भी changes नहीं हो रहे, तो हमारे पास जो state हमारे पास exist होगा वो liquid state ही होगा. तो देखिए कितना simple है. That's how we understand the concept behind the all the questions. That's why, because same question will never ask in the GATE exam. Okay, so we have to learn the concept behind the question. Okay, so if you like this type of series and this type of question pattern, so please like my video, share with your friends, and please subscribe to the channel. Thank you and have a nice day.